For over 3 billion years, life on Earth was caught in a brutal cycle of reaction. Volcanic eruptions choked the skies, oceans boiled, and ice ages froze the planet solid. Any organism that survived did so entirely by adapting to the chaos. Roughly 6 to 7 million years ago, a shift in global temperatures caused the thick African jungles to recede into open savanna. To navigate this exposed terrain, a new lineage of primates evolved the ability to walk upright. As these early hominins migrated, the local climate dictated their physical forms. To endure the freezing temperatures of Pleistocene Eurasia, species like the Neanderthals developed stocky bodies to conserve heat and large nasal cavities to warm the frigid air. Homo sapiens arrived with massive, energy-hungry brains and complex stone tools. Yet even with these advantages, early humans operated exactly like the animals they hunted. They were nomads, constantly chasing migrating herds and seasonal rains to avoid starvation. If an entire tribe of early humans lived and died in a region, they left almost zero evidence behind. Aside from scattered bone fragments and the occasional sharpened rock, the planet quickly reclaimed every trace of their existence. For 99, relying on predictable crop cycles tied these growing cities to specific geographic coordinates. A localized drought or a slight shift in rainfall patterns now meant total famine, because the option to pack up and walk to better hunting grounds was gone. By anchoring themselves to the soil, humans made a strict trade. They could no longer outrun the volatility of nature, so they had to figure out how to force nature to accommodate them. When tens of thousands of people occupy the same few square miles, entirely new threats emerge. Standing water breeds insects, waste accumulates, and rivers flood homes. Survival required carving up the landscape. In the Indus Valley, over 4,000 years ago, engineers laid out entire cities on geometric grids. They built enclosed, brick-lined drainage channels beneath the streets to flush urban waste away from the population and curb the spread of disease. In Egypt, the landscape was mobilized as a projection of sheer authority. Millions of tons of limestone were quarried, transported, and stacked to construct monuments intended to defy time itself. In ancient China, expanding agricultural hubs faced total ruin from the Yellow River's massive floods. Under Yu the Great, laborers spent over a decade dredging channels and carving deep trenches to manually redirect the flow of the water. Moving mountains and rerouting rivers allowed ancient societies to stabilize their local territories. It proved humanity could engineer its way out of environmental limits. By the mid-20th century, this localized engineering scaled up rapidly. Following the Second World War, a period known as the Great Acceleration began, as population spiked and global consumption multiplied. We extracted millions of years of stored solar energy in the form of coal and oil, pumping it into mass production lines and combustion engines. This mass burning began injecting massive volumes of carbon dioxide directly into the atmosphere. At the exact same time, humanity unlocked the ability to split the atom. Above-ground nuclear weapons testing introduced completely synthetic, highly radioactive isotopes into the environment, materials that had never existed on the planet before. Scientists refer to this transition as the proposed Anthropocene epoch. It marks the moment where human activity surpassed tectonic plates, asteroid impacts, and solar cycles to become the dominant planetary force. We moved beyond stacking bricks and drudging rivers. We began rewriting the chemical composition of the oceans and the atmosphere. If geologists drop a drill bit into the Earth's crust 10 million years from now, what hard physical evidence will they find to prove we were here? They would look at places like Crawford Lake in Canada. The water here is so deep and still that the mud at the bottom settles in perfect, undisturbed layers, creating a pristine annual archive of global atmospheric conditions. This diagram displays the chemical breakdown of those sediment layers. For centuries, the baseline is completely flat. Then, right at the layer corresponding to the early 1950s, there is a sharp, violent spike in plutonium-239, carried across the globe by the wind from hydrogen bomb tests. Looking closely at that exact same slice of mud, two other lines rocket upward in perfect synchronization: carbon isotopes from the sudden explosion of fossil fuel burning and nitrates washed into the ecosystem from the mass application of artificial agricultural fertilizers. Trapped inside those layers is an explosion of technofossils. Synthetic microplastics, cast off from water bottles, fishing nets, and industrial runoff, are now embedded in coastal sediments and deep ocean trenches everywhere on Earth. The accumulation of this material recently crossed a mathematical threshold. Researchers calculated that by the end of 2020, the sheer tonnage of concrete, metal, and plastic we have manufactured officially weighs more than all the living plants and animals on the planet combined. We started as fragile scavengers, leaving behind nothing more than scattered stones in the African savanna. Today, we are laying down an indelible, radioactive stripe across the geologic record, etching the story of our ambition directly into the stone of the Earth itself.